Hi, I'm back again with another video. Okay, I'm joking. So this is another video on some exercises on chapter 2.6 force. Some questions we did in tuition. Apparently, these are from O level, so it's supposed to be a little more difficult. So yeah, the question is: a stationary object of a mass 4 kg is pulled by a horizontal force of 20 Newton on a rough surface that exerts a frictional force of 8 Newton. So the first question is to calculate the acceleration of the object. That was simple. You just use the formula F net equals to ma. So F minus frictional force equals to ma, which is where m is 4 kg. Okay, because they said it's 4 kg. And a, we're supposed to find a. So the force applied is 20 newtons, and the frictional force that's acting on the object is for 8 newtons. So you have 12 equals to 4a, where a equals to 3, ms negative 2. So the second question is to find the velocity of the object after 4 seconds. So to find this value, to solve this question, I used the acceleration formula. Okay, so where a equals to v minus u over t. So since I know that the object was at rest, okay, it was stationary before this, so its initial velocity was 0, and acceleration is 3 because I calculated it here, and the time taken was 4 because they said after 4 seconds. So bing bang boom, you get 12 ms negative 1. So the second question is based on this very awfully drawn diagram. A force of 500 Newton pulls a mass of 4 kg through a smooth pulley as shown in the diagram. Calculate the acceleration of the mass. Okay, so here, look at this. This pulley, because it's smooth, no friction will be acting on on the object. Okay, there's no frictional force. Okay, so yeah, and also to find the force that's acting on this, that this object is exerting, okay, you're supposed to use the formula W equals to mg, which is the formula for weight. Weight equals to mass times gravitational acceleration. And also one thing about gravitational acceleration, if the question doesn't state the value of gravitational acceleration, you're supposed to take 10 ms negative 2. Okay, jangan pandai-pandai ambil 9.81 ms negative 2. Yeah, use 10. Okay, so this is actually just a visualization for the question is. So this is the 4 kg weight. This is the force that this mass is exerting, and that is the motive force. And this is the direction of the force. I want it to go this way. Okay, see it? Yeah. So I'm gonna flip page. Okay, so like I said, W equals to mg. Okay, W equals to mg to find the force that this weight is exerting. So m is 4 kg, gravitational acceleration 10 because they didn't specify, so it was 40 Newton, and F net equals to ma, where since there's no frictional force that's acting on this object, you have to minus the weight because the force that you are exerting on the object has to overcome weight to actually move it. Okay, the weight of the object. So the weight of the object is 40 Newton, and the force applied is 50. 40 minus 50, you get 10 equals to m is 4a, you want to find a. So 10 equals to 4a, bing bang boom, a equals to 2.5 ms negative 2. So now this is the question that I got it wrong. Okay, so this is how the diagram looks like. Okay, so two bodies of the mass of 3 kg and 7 kg are hung as shown in the diagram. Initially, both of the mass are held by hand force. Calculate the acceleration of the masses when the hand force is released. So by hand force, I mean I'm holding both of these objects in my hand so that none of them will like fall. Okay, so I'm holding both of them in my hand. So this is the motive force because this clearly has a higher mass, than this. So So this would basically be my resultant force, which I'll again use the formula for weight, which is W equals to m2g, because there's two masses here. I call this mass as m1, this mass as m2, and this motive force, to find the force for this object, I'm using W equals to m1g, because both of them are exerting the force that can be calculated using the formula for weight. Yeah. So to do this question, oh my god, my legs. To do this question, it's F naught equals to MA, okay, where W1 minus W2, and W1, sorry, I didn't write it down. W1 is this, and W2 is that. Okay, bing bang boom. This minus that. Okay, so W1 minus W2 equals to M1 plus M2A, because technically both of them are moving. Okay, both of them are moving. So W1 is 7 times 10. Yeah, 7 times 10, because gravitational acceleration is 10. And W2 is 3 times 10. Yeah, 3 times 10 equals to 7 plus 3A, because M1 plus M2, M1 is 7, M2 is 3. So you get 70 minus 30 equals to 10A, 40 equals to 10A, A equals to 4.0 ms negative 2. Yeah.